Okay, when we're talking about sensation and perception, when it comes to the stimuli that we respond to, the light, the sound waves, the chemical senses, the chemicals in the air, and so forth, we are not. There are certain low levels we are unable to detect these kind of stimuli. If the light is very, very dim, we may not see it. We're not going to be able to see. If the sound is very, very soft, we're not going to be able to hear it. So, one of the things that people who are interested in signal detection theory, they study how we respond to stimuli, what magnitude of the stimulus humans are able to detect. Different animals can hear sounds that we can't hear. Bees, for example, can see ultraviolet light. We cannot. So there are certain kinds of thresholds. Dogs have a very powerful sense of smell that humans do not have. So we're not able to detect very faint smells like other animals can. And likewise, there are individual differences even among human beings. Some people have the ability to detect very slight differences in tastes. Like, for example, a professional wine taster would be someone who has a very, very sensitive and a low threshold for various tastes, differences in taste. So, so let's talk about some of the terminology that's used in signal detection theory. So we've got the concept of the absolute threshold. And it can be defined as the minimum amount of energy an organism can detect 50% of the time. This illustrates also that there is a gray area. There is no single one line between. You can see it above the line, you can't see it below the line. There are circumstances that might make you more or less likely to see something at a particular low level of energy. So, but the absolute threshold is kind of like that point where half the time you'll sense it, half the time you won't. There's also going to be a lot of noise that can play a big role in whether or not you're going to be able to detect it. So, for example, if there is a lot of surrounding noise, you are not going to be, your threshold is going to be higher. You're not going to be able to detect the stimulus where you would if everything was quiet. So if you're trying to detect, so-called the needle in the haystack, for example, if you take away the haystack, the needle is going to be pretty easy to see. But within the haystack there, that's the noise. That's the irrelevant stimuli that you are not interested in. So that's what makes it difficult. So, for example, if you wanted to test somebody's absolute threshold, if you're looking at you're looking at a light bulb that is being turned on at very low levels, like a dimmer light, and it's starting to come on. You don't see it now. You start to see the light. Okay. So your absolute threshold is the point at which you see the stimulus. From your perspective, you were completely unable to sense the stimulus. At the absolute threshold, yeah, you sense it. And remember, your absolute threshold can change depending on conditions. If there's a lot of noise in the background, if you're distracted by something else, if you're tired, that's going to affect your threshold. Okay? So here are some examples of absolute sensory threshold. And again, this may be true for most people, but not everybody. A candle flame at 30 miles on a dark, clear night, presumably you'll be able to see that candle light from 30 miles away, but only about half the time. And that would indicate an absolute threshold for vision. For hearing, a ticking watch at 20 feet under quiet conditions. In those conditions, yeah, you'll be able to hear it maybe half the time. Now, if there's a lot of other noise in the room, forget about it. You're not going to be able to hear it at all. That reflects the noise. Smell one drop of perfume diffused through a 3-room apartment. Yeah, you'll be able to smell it, but maybe only about half the time. Teaspoon of sugar in 2 gallons of water. You'll be able to taste the sweetness, maybe about half the time. Finally, the wing of a fly falling on your neck from a distance of 1 centimeter. There we have an absolute threshold for touch. And again, it varies for different people. And that also is reflected in signal detection theory, that your thresholds vary. So now let's talk about a difference threshold, because that's another thing. It's not just that we're looking for the appearance of a stimulus or the non-appearance of it. We are also looking for changes in stimuli, changes in the brightness of a light, changes in how something tastes, rather than do you taste it or do you not taste it, can you sense a difference between 2 stimuli? And that's often important. You need to be able to detect when circumstances change and be able to adjust accordingly. So the difference threshold, the minimum difference needed to notice a difference between 2 stimuli. This is also called a just noticeable difference. And again, kind of similar. About half the time you'd get it, half the time you won't. Similar to the absolute threshold. So in other words, there needs to be a sufficient amount of change, or sufficient percentage of change, really, in order to be able to detect the change. And you'll, the larger the initial stimulus, or the stronger, the more energy in the initial stimulus, the greater that difference is going to have to be before you're going to notice it. And this is reflected in Weber's law. 2 stimuli must differ by a constant minimum percentage. Again, not a constant amount, but a constant minimum percentage in order to be perceived as different. Okay? So here's an illustration of the difference threshold with the light bulbs again. No, you don't see the light. Yes, you see it. But now you're noticing the difference between where you see one is brighter than the other. If any of you have ever, if any of you wear glasses and you recall going to get your prescription checked for your eyeglasses or your contact lens, remember they put you in the room, they asked you to look at an eye chart, and they put this thing in front of your eyes where they switch the lens, and they say, which one looks better, 1 or 2, 1 or 2, 1 or 2, and you tell them which lens looks clearer. Well, sometimes you're going to find that 1 and 2 look exactly the same, and you don't necessarily know what to tell the eye doctor. They look exactly the same, doc, but you feel you have to pick one. Well, the reason why the 2 lenses look exactly the same is because it's really below that difference threshold. You're not noticing any difference in the light pattern that you're receiving. Therefore, it's below your threshold for noticing the difference in those lenses. And that's when the prescription is very close together, it's not necessarily going to make much of a difference whether you get one or the other. But again, just recognize that sometimes you're not going to see a difference. Let's go back to Weber's law for a moment and recognize that the change has to be a constant percentage at a minimum before you'll be able to notice the difference. If you think about a food manufacturer or a drink manufacturer, they want to change the flavor of their drink. They want to make the drink sweeter. They want to make the potato chips saltier. Well, how much more salt do they need in order for people to detect the difference in the taste? How much more sugar do they need to add to the drink in order for us to perceive it to be sweeter? So let's say we're talking about a manufacturer of a soft drink, and they're going to add sugar. They say, our product, we want to make our product sweeter. We feel that it'll sell more if it's sweeter. So, all right, so let's add a certain amount of sugar to the formula for our drink. Well, if they don't add enough sugar to pass that difference threshold, then customers are not going to notice the difference, and it's unlikely that their sales are going to increase. Furthermore, they're already spending extra money on the extra sugar, and nobody's noticing it. So they need to recognize that the taste has to that it has to change by a percentage amount, not just an amount. If you are a weightlifter and you can bench press 200 pounds, if I added a 1 pound weight to each side of the barbell that you are bench pressing, well, you're probably not going to notice that extra 2 pounds, because 2 pounds added to 200 is only a 1% increase, where according to Weber's law there needs to be a 2% change in the in terms of being able to notice a difference. So 200 pounds and 202 pounds, a weightlifter is probably not going to notice the difference, or maybe very, very slightly notice the difference. Between 200 pounds and 201 pounds, probably not a chance they're going to notice it. So it's, again, it's kind of like sum this up with signal detection theory. People who are interested in this, they're trying to predict how and when we're going to be detecting these faint stimuli. How can we reduce background noise? What are the things that we could do to increase a person's ability to detect stimuli? Again, being able to detect stimuli is very important. Being able to detect danger. If you're an air traffic controller, for example, if you are looking for enemy ships coming through your way, you need to be able to detect it. So if you're operating radar, or if you're operating air traffic control or whatever, you are going to really need to be able to detect signals very well. And so people, signal detection theorists, they're interested in trying to improve the way in which we can detect signals. And there are various factors that have been discovered that can show how someone's absolute thresholds can actually be improved, can actually be lowered, so that you can actually detect even fainter stimuli. Your experience, if you've been doing a task for a long time, you know what to expect, and your brain is well prepared for it, well, guess what? Your threshold is going to be a lot lower. You're going to be able to detect the stimuli very much more easily than a novice. If you have expectations, if you kind of know what you're looking for, you might be better likely to find it. If you're highly motivated to make a correct decision, then you might be more likely to detect something. If, however, you're very tired, forget about it. You're not going to be able to detect the signal very well. So here's like a signal detection matrix, and you can probably think about this from maybe a vision or a hearing test you might have had. You're listening to a sound, you're supposed to raise your hand when you hear a sound. Well, some of those sounds are nice and loud, and you can easily hear it. Some of them are very soft sounds. You may not be able to hear it. Some of them are high pitch, some of them are low pitch. And the idea is, you raise your hand when you see it. So if the sound was played and you heard it, yep, that's a hit. You're correct. Yes, I hear it. Or if it's there but you miss it, if it's very low sound, you don't raise your hand, then you missed it. You made a mistake. Likewise, if you don't hear anything and you don't raise your hand, then you're making the right decision. But sometimes you might raise your hand. You might have think you heard something, but really didn't, and that would be a false alarm. So these are the possibilities when we're talking about charting someone's ability to detect a signal.